Okay, so let's say we have a particle forced to live between 0 and L in the x direction, and it's in a state given by this function. So 1 over root 2 times, say, sine pi x over L e to the minus I E1, where E1 is the lowest energy for this object, plus sine, sorry, let me put let's put it here. Sorry, let's keep the certain quantities in the appropriate place. So let's have a root 2 over L, so that each function is normalized, plus, I need it here as well. Didn't need to erase the plus sign, plus root 2 over L sine of 2 pi x over L e to the minus E2, where E2 is the next excited state. So this is n equals 1, this is n equals 2. And that's the state of the particle as a function of time. Let's evaluate the energy time uncertainty principle. Let's see what that looks like. Right? Does it satisfy that? So how do we find these quantities? Well, delta E is equal to what's the range in energy? Well, there are two energies here in the superposition, E2 and E1, so that's just E2 minus E1. Let's see, so what is that? Well, En is, what's En? N squared H squared over 8mL squared. And so E2 is 4h squared over 8mL squared. And E1 is h squared over 8mL squared. So the difference is 4 minus 3 is 3h squared over 8mL squared, if we did that right. So that should be delta E. What about delta T? Well, this is a difference, a range in time scales. What are the characteristic time scales for evolution of the system? Well, it depends on the frequencies in these superpositions. So we have 1 over frequency 1 minus 1. That's a 1 minus 1 over frequency 2, right? Because this is T1 and this is T2, meaning the periods of oscillations associated with these functions. This is the same as 2 pi over omega 1, 2 pi over omega 2. And so what do we get here? 2 pi times, well, let's just write this out, 2 pi over omega 1 minus 2 pi over omega 2, where omega is, here it's E1 over h bar, here it's E2 over h bar. So what does this reduce to? It reduces to 2 pi times h bar over E1 minus h bar over E2, which looks like h bar is h over 2 pi, so we have an overall h out here. Here we have E2 and E1, so we have 8, this is h squared over 8ml squared minus let's see, we have E2 here, and we said that that's 4h squared over 8ml squared, which we flip, of course. So this looks like we have an ml squared over h times 8 minus 2, which gives us 6ml squared over h. And so where are we? Delta E times delta T is equal to 3h squared over 8ml squared for delta E. That's the range in energy, and the range in time is 6ml squared over h. And that gives us, so we have a factor of h. We get 3 here, and 3 times 3 is 9. So we get 9h over, so we're dividing by 2, and so this becomes 4. So we have 9h over 4, which is greater than h bar over 2, because h bar over 2 is h over 4 pi. And so the energy time uncertainty relation for this state is satisfied.